Hello everyone, this is Niza School of Mastery and you're welcome to today's class again. So today we are considering stability of an atom, the stability of an atom. Is it not good to know that atom can be stable? Yeah, some may not know. That may be a new information, but we are just learning it now that atom can be stable. So the question is this, how do we know when an atom is stable? Alright, so for example, if I have a chair in my room or in my class, I can know when that chair is stable. How will I know? It will definitely have four legs, right? Well balanced, you can, when you shake it, you will know that, oh, this thing is stable. Alright, I can know when my chair is stable. I can know when my locker is stable. I can know when things are stable. But the question is, how do we know when an atom is stable? Because the point is this, we have not even seen an atom before. Talk less to know how to know when it is stable. But in this class, we're going to learn how to know that an atom is stable because atom can be stable. So the first information is this. Number one, we are knowing that atom can be stable. And secondly, we want to know how to know when an atom is stable. Is that okay now? So let's read. When is an atom stable? So let us learn when an atom is stable. Okay, an atom is said to be stable when it has completely filled orbitals, shell. When I say orbitals, I also mean shell. An atom is stable when it has completely filled orbitals. What does that mean? That means there's something called a completely filled shell. I'm sure by now you know what is shell, and you know electronic configuration. I'm sure you know that by now. In case you don't know shell and electronic configuration, you need to go back to the previous classes and go and check them before you continue this class. Okay, don't force it. If you don't know, go back and check. All right, so I go on. So when it has a completely filled shell. So when does it mean that a shell is completely filled? What does it mean when we say a shell is completely filled? Oh, that means it is full. Is that correct? That means it cannot take more. For example, if I say that your cup is filled, that means if you put extra, it will pour. It can't take more. So when I say a shell is completely filled, that means that particular shell cannot take more. Are we together? You're getting that right? All right, so the question is, how many can a shell take? From our previous classes, we learned that a shell can take up to 8 electrons. You remember? Yeah. Meanwhile, your first shell can take 2, right? Your second shell can take 8. Your third can also take what? 8 electrons. So the point is, when it is 8, that means it is full. So if it's not 8, it's not yet completely filled. But if it's already 8, that's for the second shell and the third shell. We say it is filled. So that means an example is this, neon. What is the electronic configuration of neon? The electronic configuration of neon is 2, 8. Like I said, if you've not learned electronic configuration, if you don't know how to do it, you need to go back and check the previous classes. So the electronic configuration of neon is what? 2, 8. 2, 8, is that correct? So that means this is it here. Neon is 2, what? 8. So neon has a completely filled shell. You see that now? Because it has 8 electrons on its what? On its outermost shell. It has 8 electrons, so it's already filled. So that kind of atom is said to be what? To be stable. How did I know? Because it is completely filled. Alright, if I give another example is argon. What is the configuration of argon? Argon is atomic number 18, so it has 18 electrons. So the configuration of argon will be 2, 8, 8. Are we together? 2, 8, 8. That means it has what? A completely filled shell because it already has 8. So it's already completely filled. Okay, it is completely filled because it has 8 electrons in its outermost shell. I will learn that's how to know when an atom is what? Is stable. It is completely filled. So now question is this. When is alright? When is an atom not stable? So an atom is not stable when it does not have a completely filled shell. For example, let's say we have two 8, 1. That's not completely filled because this particular one has 1. It can still take 7. So let's say we have 281, 287, 283. So the question is, amidst your first 20 elements, all right, the only stable atoms are helium, neon, and what? And argon. Those three. Your only stable atoms are what? Helium, neon, and argon. What is the electron configuration of helium? Let me write it here. Helium is 2. That of neon is 2, 8. And that of argon is what? 2, 8, 8. So neon is 2, helium is 2, 8, and argon is 2, 8, 8. So those three are the only stable atoms in the first 20 elements. Not all the elements, just the first 20 elements. Are you getting that now? So some may ask, helium is 2. Why is it stable? Why is helium stable? It is just 2. Yeah, helium is 2. Why? Because it has just one shell. You know, right? From the previous classes, you already taught that. Helium has just a shell, and that shell can take how many electrons? It can only take 2. And it already has the 2. That means helium is completely filled. Because you can't add one more to that particular helium. If you add one more to that first shell, it will go to another shell, right? It will become 2, 1. It will go to the next shell. So you can't add one more electron there. Let me remove it. You can't add one more electron there. Okay. 8, yeah. Alright, so helium is completely filled because it has just one shell, and that one shell can only take 2. But for the other 2, neon and argon, so they can take 8 each. So 8 electrons, 8 electrons, because they have more than one shell. So until they are 8, they are not filled. So these are the 3 atoms that are completely filled in your first 20 elements. So other elements, the remaining 17, are not stable. The remaining 17 are not stable. You can go back to your notes and check the configuration of the remaining. They are not stable. Is that okay now? They are not stable. So group 1 is not stable, group 2 is not stable, group 3 is not stable, group 4, group 5, group 6, group 7, they are not stable. The only stable one is what? Your group 8, or your group 0. And that's why we also add helium. If you check a periodic table, helium is in group 8, not in group 2. We don't add helium to group 2 because helium is stable. So we add helium to group what? To group 8 in the periodic table. Although it has 2 electrons in its outermost shell, it should be in group 2. But we don't add it to group 2. We put it at group 8. Is that okay now? Because it is stable. So we add it with the stable ones. So aside the group 8 elements, the other elements are not stable. Is that okay? So what's the question is, what will they do? They are not stable. So what will be the effect of that? The fact that they are not stable, what will happen? What is the outcome? All right, before we say that, let's read the notes, okay? In chemistry, it is referred to as octet structure, or in special cases, duplet structure. What does that mean? So anytime I say an atom is stable, that means it has a completely filled shell. So I would say it has an octet structure from the word oct, O-C-T, oct means 8. That means it is completely filled. It has 8 electrons in the atom's shell. So we say octet structure. So in this particular classes, from now, if I say octet structure, I'm trying to tell you that it is what? It is filled. Alright, another word we use is duplet structure. And that's for helium. No, helium is not up to 8. Helium is just 2, but it's stable too. So I can still say duplet structure for the case of helium. Alright, but for the case of other ones, which is helium, neon, and argon, I would say octet structure. That's the name we give to them. Okay, let's read on. Therefore, the only stable atom among the first 20 elements are helium, duplet structure, then neon and argon, octet structure. Now I was talking about the other ones that are not stable. What we now did to? Let's read. So the other unstable atom try to become stable. Let's stop there. So those ones that are not stable, they try to become stable. That's the goal. Because we are not stable before. So that's what they want to do. They want to become stable too. They want to become like helium, neon, and argon. They want to become stable. And how do they do that? Let's read. And they do that by seeking for electrons to add up to their shell to attain completion, which is the octet structure or duplex structure, as the case of hydrogen. I will explain that. So they try to be stable. So in trying to be stable, they look for they will be looking for electrons to to add up so they can become complete. They are not complete. That's why they are not stable. They are not completely filled. So they want to be completely filled so they can be stable too. So they start to look for what? Look for electrons up there, here and there to become what? To try to become stable. Is that okay now? So I will stop that particular class there today. All right. So in another class, I will not tell you how they get the electron. How they get the electron. I will not tell you how they get the electron. But in this particular class, all we learned was their stability. We've learned that atoms can be stable. And how do we know when they are stable? We know when they are stable by their what? Electronic configuration. So I was saying that if you don't know electronic configuration, you need to go back and watch it. All right. So we know how they are stable by their electronic configuration. So when we check the electronic configuration, those ones that has a completely filled shell are the stable ones. And they are just three: helium, neon, and argon. And the rest that are not completely filled are not are not stable. And then they try to be stable. And how they do that? They seek for electrons so that they can add up and become completely filled. Alright, so that will be all for today. Try the questions, and then in the next class I will take you through how they become. I'll take you more on how they try to become stable. I mean the unstable ones. We will now look in depth into what they do to become stable so that you can understand very well. And don't forget to like and comment and follow this page. All right, take care.